Good morning. I am Anatol Levin. I'm president of IMTC, and I have a pleasure of welcoming you to this IMTC annual member meeting. So it's interesting, it's exciting, it's really an unusual, well, let's forget about unusual, but it's really interesting. We are 21 years old as an organization. It was a great pleasure for me to see many familiar faces, people I did not see in 10 years, who came in, they maybe rejoined the organization recently, and or they simply interested in seeing what's going on. But it's really, really exciting that IMTC is continuing to bring value and continuing to go with their mission, with our mission of really making technology, communication technologies interoperable and useful and available for everybody. So before we talk about these 2 days, I would like to thank the sponsors. Big thank you to Microsoft. Bernard had been instrumental in getting us here and helping us to get into this beautiful conference center. So big thank you to Microsoft and LifeSize. So what is ahead? I think we're looking at 2 days of very interesting program. You're going to hear a lot of presentations about really cutting-edge technologies, things like software-defined networking, which really became an acronym over the past year or two, the SDN. And now it's becoming real, and you're going to learn about it quite a bit. We're going to talk about all the latest advances in video coding and audio coding. You're going to hear reports from all of the IMTC activity groups, which still moving forward with a lot of with the work they've been doing for many, many years. So we have a great keynote from Microsoft, and you're going to hear what Google is all about in terms of the video coding, again, and the latest advances. So these 2 days will be fully packed. We're going to hopefully keep you interested, keep you occupied, keep you busy and glued to your chairs. So we're going to have fun in the evening. We're going to go to a restaurant, which is a lot of local people said that's the place to go to. So we'll find out. So anyway, so that's going to be 2 full days for you to learn, to network, to talk to each other, and to see how we can move it all forward. And the important thing for us, important thing for IMTC would be to get your feedback. Yes, we do different type of things. We work in different directions. We have a number of activity groups. But IMTC, really, the goal of IMTC is to service its members. So the best thing we can get from all of you is your feedback. These are the things which we are missing. These are the things we should be looking at. These are the technologies we need to be looking at. And this is what should be improved. And so this is our all members meeting. And that's really, this is your time to talk back to the organization and tell us where to go and what to do better. And with this, let me introduce our keynote speaker, Todd Haugen, General Manager for Microsoft. Todd spent his entire career in designing, developing, and releasing innovative software. Todd is currently General Manager of Connectivity Engineering at Microsoft, where he's responsible for Skype, Wi-Fi, carrier relations, Wi-Fi relations, software-defined networks for diagnostics and dynamic provisioning, as well as industry alliances for those areas. Please welcome Todd.
Hi, folks. This is a great group to get a chance to present to. When you look at beforehand, I was actually looking through the list of companies and folks that are attending, and what's really interesting is this group is setting the future vision and direction for unified communications and media and the internet. And when you look at the problems in software, some of the really hard problems, a lot of them exist right here. That's what's fun, right? And so the idea that I get to come up here and talk to you about software-defined networking and how it's going to impact unified communications is great. When we think about software-defined networking, we often think about the data center, right? This is where it started. Over the years, it's expanded out. Software-defined networking is no longer just at the data center layer. If you look at what Google's doing with path definition and dynamic rerouting of content, right? It's now a internet backbone technology. And what we're going to talk about today is actually, when we talk about UC SDN, that's what we're talking about, it's really application SDN. We're getting it all the way up into the devices and software. So that's what we're going to spend today talking about. I'm not going to take the full time, but we'll have some time for Q&A at the end. So let's get going. So this is all old news to you folks, but for us, it just sort of helps level set. When Microsoft talks about unified communications, it's all about the different modalities, right? We have Yammer and discussion groups and 3 different chat applications and 2 different email architectures. And when you think about all those things, we're aggressively in the process of bringing those together in a unified communications front. And that allows us to unify the end user experience into a single simplified experience. But what really matters is it allows us to unify the administrator's experience, right? And when you think about it, that's the biggest challenge with communications today is this diverse portfolio of communications tools. How do the administrators themselves know how to set up, manage, and run these? And unified communications, Microsoft's about bringing those together. So that's been our biggest challenge, right? So think about how our email evolved. We had Hotmail, right? And we had Exchange, and we had Outlook, and how do all those technologies all come together in a single fashion? And then we have Link for chat, and we have Skype chat, and we had MSN chat, and how do we bring all those technologies together? And when you think about that, right, this has been the story for Microsoft over and over again, right? We either acquired or built technologies that became mainstays of our daily lives, but one was consumer and one was enterprise, or one was big business and one was small business. And bringing those together under a single umbrella is what we've been investing in heavily over the last 5 years, and you're going to continue to see that. We really have only 2 groups left that have significant responsibility over communications today. And that's for us, that's a huge win, right? We have the Skype division, which has Skype and Link and all the associated technologies that go along with that. And we have the Exchange group, which has all of the email and all of the server components. And those 2 groups now sit very close to each other. They used to be entirely different direct reports of Satya. Now they're under a common direct report, and they work together on a daily basis. And so we continue to make progress in bringing these things together, and I think that's a huge success for us. So when we talk about unified communications, though, and the challenges, sure, we've got architectural challenges and we've got design challenges and all the standard software execution challenges that I just talked about. But what about as an industry? What does the industry face as a set of challenges, right? And so let me just give you a little anecdotally. When we look at Microsoft and we look at unified communications over our infrastructure, right, it's hard. We have buildings that have very poor call quality. And why is that? What's happening? And what we find is our ability to go on a single call and look down into the network and figure out what the problem was, actually debug it, so we can build towards carrier-grade communications in UC. We don't have that visibility. It's really difficult. And so I sit in building 6, and literally right across from me is building 10. Building 6, one of the best buildings on campus for communications. Building 10, one of the worst. I spend a ton of time over in 10 trying to figure out what the problem is. It's not simple. It's not the software, right? You guys all know how this works. The software works great here with no changes. It works terrible over there. What's happening, right? And it's a network configuration problem. And the only way we can get in and figure that out is having the right visibility and diagnostics. And SDN is one of the things that really helps us drive there. Quality of service. Setting up unified communications depends on this. You can't just plug it in and say, great, let it have at the network. There's too many things competing for that scarce network resource. And so quality of service, we all know, we go through a bunch of time, we all get it set up, and what's the first thing that happens? It drifts, and you're like, seriously, I just set that up. And so how are we gonna simplify the complexities of quality of service? BYOD, how many of you go palm slap? Right? Like, this is the thing. It gets more and more diverse, not less. We keep thinking it's going to get easier, but every time somebody makes some big breakthrough and we get BYOD easier, the diversity of devices expands and explodes, and so the number of scenarios people are using it on. So we really started to get our handle around phones, and we were all feeling really good about it a couple years ago, and then tablets came and just stomped us. Right? And so expect that trend to continue, and how are we going to help manage in that world? And then really, if we look at the total problem space for unified communications, we're getting 60% poor call quals from one technology. One. Anybody have any idea what that one technology is? Wi-Fi, exactly. I was expecting more of a chorus of Wi-Fi. But yeah, it's Wi-Fi that drives that problem. And that's because spectrum is the scarcest of all resources, right? When you think about the spectrum that's available to us, the unlicensed spectrum that's available to Wi-Fi, it's far, far less than the actual utilization. In fact, I have a slide that I do in our longer presentation that talks about the percentage of data that is transmitted over unlicensed spectrum is 10 times the amount of data that's transmitted over licensed spectrum, but licensed spectrum occupies 10 times the amount of spectrum that unlicensed spectrum does. And so it's totally upside down, and it's like, how are we gonna fix that? And so we're talking a lot about how we can help with that part of the problem set. So when we talk about unified communications SDN, right, this is where we were 2+ years ago when we started. We realized it was too hard to set up a network to really support unified communications. And what we realized is it wasn't a simple problem. It's not just saying, how does our server work and how does our client work and what's the problem there, right? It's more complex than that. It's how do those two components work, and how do the devices behave, and how do all the network elements behave, and it's all that together. And so we're about pulling those together in a cohesive fashion. So you'll see in a couple of slides really what's the role SDN can play in all those different tiers. So when we talk about it, what's kind of the architecture? It's a pretty straightforward, birthday cake architecture. We've got applications running on the top. There's an SDN controller platform, and this is where all the rules are housed, right? This is the important stuff. This is how a network administrator is able to say, oh, here's how I want Netflix to behave on my network, right? And Netflix, unlike YouTube, we know is just purely for entertainment. It's pretty hard to block it. Some people do. Some people actually some enterprises are draconian enough to take that step. It's not technically hard to block, but from just a cultural standpoint, it's kind of funny to block something like that if they want to watch it at lunch or something. But you want it to always behave with the calls. When you're making calls, right, that's an application that can't take precedence. But when you think about YouTube, YouTube's got a bunch of very logical uses, doing market research and things like that. And so how do you tell the network how to behave, how those two applications should behave relative to your CEO's conference call, right? That's a real challenge, and that's really what that controller platform is able to do. And it drives the network elements to be configured and set up the way that matters, the way that works for you. So what does that look like in sort of practice? And this is what I was saying. it's really not just about UC, it's about all the applications. So if you think about, so let's just take file transfer systems for a second. File transfer systems have evolved over the course of the last 5 years to behave really well on your individual device. Remember, it used to be that if you kicked off file transfers, it would hog all your machine and you'd have to go in and pause it and make it so that you could continue working. That doesn't exist anymore, right? All the file transfers behave properly until you get up and go to the bathroom. And then it just takes over your machine and goes, which is what you'd expect. The problem is the network can't handle that, particularly multiple people doing that at the same time as we have a multi-party high-def video call, right? Those things don't play very well together. But I don't care how fast that file transfer goes in general. Sometimes you might, but in general you don't. And so being able to have the application, the UC application, talk to the network and say, I'm making an important high-def multi-party video call. I need you to try and get me bandwidth. And then having the network tell things like file transfer applications, hey, we're busy right now, use left, back off your transfer rate. Right? That's the kind of coordination we're going to need. In another 2 to 3 years, the UC applications themselves are going to behave so well with the network, right? That's what this initiative is about. And everybody, a large percentage of the vendors that we work with are already deep into enabling their products with UC SDN. Nectar's here today. They're one of those great partners. I know other folks have done great work in that area as well. And so in 2 years, that's not going to be the problem. The problem is going to be when you're trying to get at that scarce network resource. Other applications need to behave properly as well. And so as a group, it's going to be important that we're pushing on applications to take on that integration point, to respect the SDN, the application level SDN in the network. And so those applications talk to the controllers themselves. Well, actually I have an architecture slide in a minute we can go to. And so what are we really talking about? Well, the key here is it's not that SDN sits in the call path, right? That's one of the big failings of solutions like this. We have to ride alongside the call path. Call path has to, performance and dependability has to be preeminent. That's how we're going to get POTS grade calling over unified communications. And so the idea is let that ride alongside the call stream so that it doesn't interrupt it. And then allow the SDN controller to coordinate across the 4 big elements on each end, right? You can imagine there's 2 of these, client down to service, and then it goes network, device, and client again, right? And so how does it coordinate across all of those components? And in doing so, it allows interesting dynamic changes. It allows the client to change codec and bitrate, right? And so that's a really important thing to efficiently utilize the state of the network. Think about it in devices. One of the biggest wastes, I mean, it just maddens me. When you're looking at the network and I see all these retransmissions, I know they're getting thrown on the floor on the other end. Why the heck am I wasting my bandwidth on this, right? And just further exacerbating the problem to get more retries later. And so why aren't we able to just have the network stack on the client device just back off on retries for this particular socket? Well, we certainly can configure it that way, but you have to do it dynamic. The network itself, quality of service, we'll talk about it, we'll keep talking about this over and over again. Setting up quality of service, it's expensive and fragile, so we need something that dynamically sets it up real time. And then when we talk about the service themselves, the thing that's riding in the cloud, providing unified communications, path, setting up the actual media path, right? We were just talking about one of the data centers here in Seattle in Quincy, and the way that the paths are set up. It's a super complex, we have thousands and thousands of paths just to get out of the building. And how do you set that up in a way that really makes sense, right? You need the information from the network and from the applications to be able to set up the right configuration. So it's the coordination across all these elements that really enables the unified communications vision. That's what enables that carrier grade call quality for unified communications we're looking to see. And so what is it? What are the three big scenarios? We'll keep talking about this, right? The three big scenarios are diagnostics. Let me just go again. Diagnostics, diagnostics, diagnostics. Right? Near term, this is the thing that we're so in need of. Quality of service. And we'll talk about that a little more on the next slide, but that's a huge expense and complexity of configuration we need to get past. And then orchestration. So orchestration, I'll give you guys a little anecdote because it just happened at my house and it was so frustrating. So I'm there playing Xbox with my son and a little box pops up that says the performance of my Xbox might be degraded, might be degraded by your NAT setting. Go into your router, very inspecific, it says router. Go into your router, check your NAT settings for this configuration. I do this for a living. I didn't get up and go check my router right then. All it did was piss me off. 2 weeks later, I finally got in. It turns out they were right. It was misconfigured. I went ahead and fixed it. But it took me 2 weeks to get my ass out of the chair and go fix it, right? The device knows what's wrong. The network element knows how it's set, but it can't fix itself. And my son certainly, I'm not letting him anywhere near my router. And so that's the kind of thing that's so frustrating. And somehow, as an industry, we've got to put the tools and the platform and the capabilities in place to start addressing that. And so when we specifically talk about quality of service, you guys will sympathize with this. So somebody stamps their foot and says, I need unified communications to work and be quality on our network. So you go out and you talk to these guys and it goes back and forth, back and forth, back and forth, like 12 times. Something ridiculous like that. And finally, it's set up after weeks of work where the person's going, kicking you in the ass, kicking you in the ass. How come it's not there yet? What's taking you so long? I don't understand. It's just a network configuration. It's not that simple. You try and explain it and you show this picture and they're like, I don't want to see this. Just get it done. Right? And finally you get it set up and they get like 3 calls and then some executive down the hall on the other side says, my conference room's not working the way, and then the whole thing starts to drift and it's broken. So you made this big investment and it's broken. We need to be able to have quality of service set up dynamically for the scenario real time. And so I'm sorry we don't have the time and the capability to set up to do the demo we normally do today. But we have a demo that shows a loaded network and what the MOS score is, 2-ish, turning on SDN, and it bumps by almost 2 points, sometimes more than 2 points, puts us all the way up at 4, gets us to that range that's reasonable, right? And that's just using SDN with the Wi-Fi stage, right? That's how much improvement you can get just out of the Wi-Fi stage. And so it is really meaningful. So it'll really be important for this room to help support us and help get this thing going. And so what are we really talking about from an architecture standpoint, right? The UC systems, right, they're all UC as a service now, right? They're all running in the cloud. And so it's important that we're able to interact with services that are up in the cloud. The controllers themselves, right? Really important now that those run in the cloud, right? Look at all your network vendors. They're all going to cloud-based controllers. So we support that capability. Including not just the SDN controller itself, which is the software that you all can provide or that we provide, but it's the Wi-Fi controllers themselves as well. So having these elements in the cloud, the UC system is able to communicate to the controller, which then communicates to a Wi-Fi controller in the cloud, which is then able to drive the access points and the devices in the on-prem network itself. And so when we look at this kind of an architecture, it's intended to scale to massive size, Microsoft is going to put an SDN controller in the Azure service that allows small to medium businesses to just use it, right? This isn't an area where we're like, let's go make a bunch of money. This is an area that's an enabler, right? What we really want is an SDN controller that anybody can start building off of and using, right? And anyone can do this, right? It's not a particularly complex piece of software. All it does is map scenario to network element settings. Gives the controller of the network, the administrator of the network, the ability to say, here's how I want this scenario to behave. And when you do that, right, it's able to set up those scenarios that we were talking about in the previous slide for the devices, the access points, and the software. So when we talk about UC-SDN, and again, I keep saying application SDN now. It's UC-SDN for this audience, but really we're talking about application SDN, because if it's not all applications or a bunch of the applications, we're just not going to have as much success as we'd like. So when we talk about that, it's all about quality. It's all about service quality, as opposed to quality of service, trying to differentiate those two out, right? It's all about service quality. We need visibility into what's happening on the network. We need control over that in a scalable way, right? That's one of the biggest problems. We have tons of control today, but it's not scalable, right? We have to run around to each machine and twiddle this and adjust that, and that's not going to work for us as we continue to scale. And then it needs to be able to operate efficiently at scale, and then automating those changes and get that cycle going, right? That's really what we're trying to accomplish. When we do, we're going to realize the operational efficiencies of SDN and the data center and bring them to our application layer. So I'm not sure if you guys are aware of the massive impact SDN had on data centers, right? It's like a 80% reduction in the human cost element of running a data center, right? It's massive. And that's the same kind of efficiencies that we can drive inside of unified communications, which, if we're all honest with ourselves, is too expensive today. It needs to be simpler for a higher level of quality if we're really going to see our businesses excel over the coming years. And in doing that, what we're really saying is we have to drive the agility of network operations management and configuration. That's what we're really trying to drive with UC-SDN, with application level SDN. So with this group, what's really our call to action, right? So if you're not already joined to the standardization efforts, please do so. We need more scenario. We need more subject matter expertise in those areas. We need you to start choosing SDN-enabled network elements as part of your implementations, right? So whether it's Cisco or Aruba or Maru, right? We need to take these guys, we need to push on these guys to make sure that we're deploying their SDN-enabled equipment. And then as you build out applications, either internal applications or applications you're delivering to the marketplace, please think about SDN as part of your architecture. We really, that's what we need. We need to get some momentum here. We've got a lot of momentum inside Microsoft. We've got a lot of momentum with a lot of hardware vendors. We need more, right? It's a rising tide is going to rise all boats together, and we really need to make sure that everything is taking SDN into account. So that's all I've got for today. How about some questions? All right.
Well, maybe I have a question/comment.
Don't worry, I'll repeat the question.
Oh, okay. In a couple of your slides, the codec and negotiation of codec properties, etc., was pretty prominent.
Yeah.
If we look at state-of-the-art or leading-edge codecs, like, for example, in the communication end, AAC ELD, which is using FaceTime, and more importantly, EBS, which is the latest 3GPP codec for high-quality mobile communications, the bit rates are so low that if the network cannot handle, let's say, in the case of EBS, 13 kilobits per second, which gives you full audio bandwidth at that bit rate, then I would say something is wrong with the network in the first place, right? So what's your take on the codec needs and requirements here?
So the question is, we talked about in the slides about the ability for SDN to set up codec and bitrate adjustments depending on the current state of the network. And given how low the bitrate requirements are for voice, why is that important? So a couple of things. One is when we talk about the bit rates for voice and Wi-Fi, a lot of times even that low a bit rate can be difficult if the network is congested. So that's certainly one piece that's important. But the other is it's not just about voice anymore. If you look at the bit rate required to deliver multi-party HD video on the network, it's a much higher bit rate. And that's really, if you look at where we're headed, I would say 3 years ago, before I joined the Skype organization, I probably had one video call a week. Now, 36 months later, I have at least one video call a day. And so I don't know what your guys' experience is. I'm sure some of it is that I'm in the Skype organization. But my bet is that a significant percentage of that change is just specifically the evolution. In fact, I noticed there's a whole sort of protocol for starting a call these days. It starts as voice, and then you talk about whether you're going to step it up to video or not, and it's a thing that happens sort of standard every call, one-on-one call I make. And now meetings, it's just assumed that all meetings have video in them now, right? And so I think as video becomes more and more prominent, that question of how we're going to handle codecs over that wireless last link, because the number of people who are going to be on desktops is going to get smaller and smaller. And when you start talking about being on your mobile handset using LTE to drive a conference call, it's going to become even more complex for us. And so it's not clear what the level is. It's just what we're finding is one of the difficulties today. And so we're saying, great, we should be able to drive the codec bit rate from there. Question?
Yeah, so what's the time frame for SDN getting into the routers? Is it just a firmware upgrade, or do we have to swap out the world's inventory of routers in the network?
So it depends on which pieces you're talking about. There's nothing inherent saying that it needs a hardware change, and so it really can just be a firmware change. It depends on the vendor. And so some vendors are looking for it to drive a refresh, and some are looking for it to be a long-term competitive advantage for why you would want to be with their product. I don't have a lot of influence over which way a company goes. But it is going to be an interesting challenge to get the industry to think about the key is not driving a hardware refresh across the industry. The key is enabling a new set of scenarios and a new set of utilization of the network. That's what's going to drive the incremental value. That's really where we want to see more. You want to drive more hardware sales on the network? Drive more utilization of the network so that people feel good about paying for it, not like, dang, I got to obsolete another round of equipment. Does that make sense?
Yeah.
Yes, Joe.
Policy and orchestration is critical. I'm curious on your view on where you see, inevitably you run into a scenario where if there's contention and choices have to be made. What's more important? Do I let the HC call go through, or do I let more voice calls go through? So the policy, everyone agrees there should be some level of policy control, but where does it sit, and how do you see kind of evolving in like an enterprise where you have to decide who wins the battle when I got to decide what I'm blocking or allowing? Because ultimately there'll be a framework to allow those decisions to be made if SDN takes off, but that control level is still very interesting.
Right. So the question is, given that that networking is a scarce resource, we're always going to be bumping up against the limits of that resource at times. So how are we going to drive the policy management for making the decisions as to which demands should be met on the network? And so if we think about back when we were talking about, when I had the architecture slide up, and we were talking about the SDN controller, the SDN manager, sort of that middle layer, That middle layer, if you could think about it, it's really says, okay, what are my scenarios, and what are the resource utilizations of those scenarios? That's what we're working towards in the standards bodies. So now there's a question: should it be, is a scenario an application, or is a scenario a general definition of what's happening? In other words, is Link a scenario and Skype a scenario, or is it video calling that's a scenario and voice calling that's a scenario, or both? And so we're trying to work through those issues right now. But the idea is at that layer, whoever is the network administrator is able to go in and for each one of the known scenarios, able to say, here's what the policy is for managing it. And so the specific example used in the question was, we have a 10-party multi-video HD call that wants to go through as part of the board meeting, and we've got 10 voice calls that want to go through. How do I decide which ones should be able to go through? And so that's clearly the responsibility of the SDN manager. How we would specifically handle that scenario is not understood yet. Sorry, I think you were next. I'll get you in a second.
On one of your slides, you showed various network components, and you had a Wi-Fi controller and also an SDN controller. I'm just wondering, how do you see those two things playing together? Like they might both have some network topology information that they know, but now there's two controllers. Which one does what? How do they play nicely together?
Okay, so the question is, when you looked at some of the network topology slides, I showed a Wi-Fi controller and I showed an SDN controller on the same slide, and how do those two play nice together? Do we have to duplicate network information? What's the actual vision of how those two play together? And so when you think about that particular scenario, there's a couple variants here. That particular scenario showed the Wi-Fi controller in the cloud, and it showed the SDN controller in the cloud. And really, it should have said SDN manager in that scenario, because the SDN manager is the one that houses the policy. There is a particular scenario where there is an SDN controller, and that's in a scenario where the on-prem equipment, where you're managing on-prem equipment that doesn't have access from outside your firewall, then you have to have effectively a proxy device that's on the network that allows you to push through. That's what we call the SDN controller. And so that slide's been mismarked there, and apologize for that. It's the SDN manager, and when they play together, really all they play together is that the SDN manager understands the scenarios and the network elements and what it can tell the network elements to do, and it pushes the commands down to the network analyst that knows that configures the actual network element itself. Last question. I'm being given the 1 minute sign. Go ahead.
So you spoke a lot about all this stuff over Wi-Fi, and the use case, especially in universities, is that I'm also mobile if I'm on Wi-Fi and I'm doing Link or Skype calls with video.
Yes.
I'm walking along a big building on campus. What's Microsoft doing in the area of roaming across the campus as related to Link and Skype, etc.?
So if you think about what is the question is, when we look at the Wi-Fi scenario, historically it was nomadic workers. Pick my laptop up, walk someplace, sit down, sit there for a call, pick my laptop up, walk someplace else, sit down, do that for the call. Now that we're on phones, that's no longer the scenario. Everybody's wandering around, and when they go mobile, the way that TCP/IP works, it holds you effectively. When you have an open stream, it's going to hold you to that base station, and so you literally walk out of range, and it doesn't know what to do. One of the things that I talked about when you saw the slide with all the lists, one of the things we want to drive capability of is the network scan rate, because and so this is what Microsoft's really doing, is saying the issue is the make before you break handoff technology, right? And so it is one of the key scenarios that we're working on in Link, is to be able to say, what's the network scan rate we're going to use on the device so that we don't burn through a pile of battery, and yet when we feel ourselves leaving, seeing a degradation of signal, we start to look for the next signal and then do a make before you break handshake and do side-by-side UC streams, and then do the positive handoff. So that's the scenario that we're working under. We recognize the need for mobile scenario support inside Microsoft as much as anything else. And so I apologize. I don't know who I'm handing off to next.
Thank you, Todd.
Yes.
We can maybe
Thanks,
just
folks.
take the last question if you want to take one more, if you don't mind.
I'm absolutely sure.
So, SDN controller, are you Microsoft planning to add one in the portfolio?
So SDN, let's say SDN Manager. SDN Controller for us is really, it's a piece of software. It's just a piece of software that rides on our edge devices already. We already have edge devices for handling NAT traversal and things inside of unified communications. And it's another piece of handling that firewall traversal. And so the code, so software to run on that to handle that is one of the pieces of code that we'll deliver in that. In terms of whether or not we're going to deliver an actual hardware component or not, that's not something I am able to comment on in detail now.
I think that's fine, but like something like Open Day Light or something, that's what you're thinking?
Yeah, that's a reasonable way to think about it. Sorry, the question was, is it something, are we looking at, when we talk about the SDN controller, is that going to be something that Microsoft is delivering as a product? And if we are looking at it, is it something that's kind of like an open daylight configuration? And so that's a reasonable way for us to think about how we're going to implement it. So, thanks, folks.
Thank you very much.